how can we utilize these advanced site characterization tools, right, to make the management more sustainable. So I'm going to talk a little bit about the same things, but from a different perspective. How can we improve sustainability at our jobs when we utilize these advanced characterization tools and all the data that everyone here talked about, 3D models and remediation strategies that we, based upon the data that we have, we can finally be able to provide new solutions, right? So it all starts when we realize that site management is hard. We don't know a lot about the subsurface. We don't see the contaminants. We don't see the geology. Geology is very heterogeneous, is very different. We cannot predict its behaviors. So when we're doing with management strategies and remediation sustainability, we need to rely on a robust conceptual site model that needs a lot of data. So Jim showed this, Peter as well before. And then there is this very interesting report that was released in 2021 from the World Health Organization, talking about urban redevelopment of contaminated sites. And it's interesting that they found in 25 case studies that the lack of information affected and delayed remediation and increased the budget and had financial implications and required change and further planning time. So we are very good at getting to the remediation very fast. We want to remediate, we want to implement the systems. But as Jim said before, if we do that with not a lot of data, it's very complex. We cannot predict when remediation is going to end. We cannot see if we're going to be able to redevelop the site, right? So they found out this actually in 25 case studies in Europe, only one was able to be finished in the predicted time. All the other 24 lacked information. And that is true for Europe, that is true for Australia, the United States, or South America as well. So we need more data. We're going too fast into remediation. And now we finally have the tools with the advancement of technology to collect more data in the start, so we can remediate better. And then now we're starting to discuss sustainability. How can we remediate with a more sustainable approach, utilizing less resources, decreasing our footprint or impact in the environment, while we're trying to recover what is contaminated. So I'm going to illustrate a little bit a management strategy in a case study that is still undergoing, but we're finally seeing the end of the contamination at the site. The site itself is a gas station that is based inside a factory, a plant, industrial area, and then remediation was undergoing in the site with a pump and treat system, right? And then it was operated for 2 years, recovered a little bit, the recovery stopped, and then the LNAP was not seen in the wells anymore. Fast forward 2 years, LNAPs are back in the wells, and they called us to restart the systems, to install new ones there, to improve what they already had, and start pumping again. And then it's all the same story. LNAPs are back, right, at the wells, at the site, after the remediation was finished. And then we told them that if they wanted, we could investigate more. We needed to investigate more to see if the LNAP recovery was possible or not. What were the primary sources? And then we were able to implement this investigation with advanced site characterization tools, triad approach, high resolution site tools, to get the data that we needed in real time. And we did that with the OIHPT system, because it's the one that is used for LNAP investigation when we have a free product there, the oil is still there. In this case, was diesel fuel from the factory machines and tractors and so on. And also coupled at the same time with the HPT, so we could actually see the lithology, the geology, the hydrogeology, where the contaminant was flowing or being stored. So we did 60 OHPT points around the site. And then we were able, this was a very, very simple cross-section that illustrated what they had before, right? They had the El Naples in the wells, shown here in red, and then some soil that they knew was contaminated, but there was no link. And the primary sources were not indicated as well. Where was the contamination coming from, right? It was not fully mapped. And then this was the OIP impacted area with fluorescence up to 100%, right? And then we were able to see the real impact of El Napo in the unsaturated and in the saturated zone. So we had El Napo above the water table and below the water table as well. So we were finally able to connect the points, see the real impact, and to identify the primary sources of contamination that needed to be fixed before we could move forward with the remediation, right? And then, based on the OIP investigations, we were able to see that the pumping could be still applicable at the site because all the HPT readings was very low. So we had a high permeable zone where the El Napo could be recovered. We couldn't use excavation because the owner could not close the gas station because of operational implications at the factory. We couldn't use chemical oxidation, this called, or bioremediation, because the contaminant mass was too large, right? It wouldn't be effective at first. But we saw that we could optimize the pumping because the pumping wells that they had there had they screened, they were not placed in the correct zones where the El Napo was present and could be removed, right? So just based on the OIP signals and the HPT data that we had, we were able to replace the well screens to target specific areas at specific locations. Not all the wells were built the same or at the same depth. All of them were targeted to focus on those the layers that we had El Napo. So this is what we got. We had 600 liters in recovered like in 2 years, and then we operated for around 2.5 and recovered almost 10,000, right, in the same site. And then we were like, did it really stabilize because we removed everything, or just because we were still missing something in there? Because the recovery was stabilizing, right, as time passed on. So this is the El Napo map that we had before. This is the El Napo that we had after. So we clearly saw a reduction of El Napo in the area, in the wells. But they were like, what about the saturated zone? Do we still have the mess there? So the client agreed to do one more OIP round at the site. So this is the difference from before and then after. We just not decreased the whole area, but we decreased the intensity of the El Napo as well. So we went from 100% to less than 20 in 2 hotspots. So we were able to recover the oil from the unsaturated zone as well, because we made everything move down there because the lithology allowed us to do that, right, at the site. So we decreased the volume impacted 3 times, almost. We went to 1/3 of the original one, and also the intensity. And then we were able to understand that the recovery was really stabilized. We couldn't pump anymore. The thing that we had here was probably absorbed in the soil, right? And it wouldn't move. So pumping was not in place anymore to keep the remediation going, so we could close the area, we could close the investigation and remediation process at the site. Then based on that, we were able to then, okay, we saw that the El Napo was stabilized, but we still have contaminants at the site. And this mass in the soil, although it was not the biggest mass anymore, this mass is going to fuel the dissolved phase in the groundwater for decades, right? If we put this in the flux model, when water flow, it's going to show that this phase is going to be there for like 100 years, 200 years, fueling the dissolved plume. So we still will have risk. The site is going to be impacted, right? So then, based on that assumption, we need to further evaluate our strategy. What can we do now? And then luckily, the client was open to excavate now. We could excavate in the area. It was the easiest. And then they were moving the gas station to another area. So excavation was the go-to option at the site, because we could predict where to excavate, how, the depths, the sizes of each area that we wanted to excavate, and then the soil we suggested to treat on site with enhanced bioremediation. Right? We didn't have mass that big of a mass anymore, so bioremediation was a good player. So excavate, remove the mass, and then on site they had a lot of space, open space to do that. We could then do bioremediation, a slower process, but a process that we can predict the end. And also excavation, because the client, due to ESG strategies of the firm, environmental impacts, environmental liabilities, he decided to excavate. He didn't want to have that environmental impact anymore. And that's also required by law in Brazil here, that we use strategies that can remove the mass, destroy the mass, or eliminate the mass as much as we can. So we developed an excavation plan with the squares that were not the same size, they were not to the same depth. So we're just excavating what we wanted to, what we really had to excavate in the area. And then we collected some soil samples after we excavated to confirm that it was there after we took the soil out. Did not have any more mass absorbed in the soil. So we were sure that we wouldn't have a mass that's going to feed the dissolved plume forever, right? And then the biopiles are now under application, so it's still going. And then we're starting now to monitor the dissolved phase in the long term, because that's going to be that's going to decrease over time because we remove the mass that's going to feed the dissolved phase forever. So with all of this that I share in the case study, the message at the end, right, is that here in Brazil, we need to prioritize techniques that remove the mass or destroy the mass, right, as much as we can. And for that to be feasible, to not spend a ton of money, we need data from the site that we can prove that we're doing the right thing at the right place. We're not putting a lot of effort in the wrong area or at the wrong depth, right? And then when we focus remediation strategies to be sustainable, we need to consider the contamination mass, right? If we use long-term strategies, mitigation strategies, we are not eliminating the risk 100%. The environmental impact and liability is still going to be there because the mass is going to be there. And how do we measure the effectiveness of CO2 emissions, footprints or impacts, if what we are trying to solve, which is the contamination mass that is still there, we cannot measure that if we're not removing, right, in the long term. We cannot see if we're being sustainable or not. At this site, excavating, which is not the prettiest approach, was the most sustainable because we removed the whole mass in 2 months of excavation, right? The contamination is gone. So although we emit a little bit more CO2 in the short term, if we put the mass of contamination that we removed in the long term, the CO2 impact is minimal. It's way less than operating in an SV soil extraction here for 30 years. The mass is still going to be there, and it's still going to need management, right? So just the final one, we need conceptual site models built tailored for each site with data that we can rely on and has a density that is appropriated for that site. So we can build different remediation strategies that we can couple together to clean the areas, to clean the environment, to recover, to eliminate human health risks, environmental impact that needs to be assessed in the short term and also in the long term. We can see an end and clearly be sustainable, right? Because we need an end, right? We cannot sustain that for 100 years of operation and stuff like that and monitoring in site, right? So we need to understand the mass, and we need to have a conceptual site model that makes sense and is built upon a lot of data that we can prove and understand. So thank you, everyone. So that's my final message.